Okay, if you survived MS Paint, I salute you. Last two problems on the page, and then we'll move on to 4.3. An angle bisector of the triangle below. We only see one that has been marked as an angle bisector, and that is AD. It is bisecting BAC. Those two are equal. They have been marked. That's the only angle bisector that we know of up here. A perpendicular bisector. We actually only, well, no. Okay, so there's two. CG is going to be a perpendicular bisector of AB. And then we know for sure that DE is a perpendicular bisector of CA because we got these sides marked. This one, you could probably make a fair guess. That's going to be a perpendicular bisector. This one we know for sure is a perpendicular bisector. We know for sure that DE is a perpendicular bisector of AC because those two segments on either side of E have been marked congruent. Okay, so if you flip your page, we're going to go straight into 4.3, medians and altitudes of triangles. And these are actually really similar, okay? Circumcenter was all about drawing your perpendicular bisectors and finding where they intersect. Incenter was all about drawing your angle bisectors and finding the place where they intersect. This time, we're going to talk about medians and altitudes and the centroid. So you should be at 4-3, medians and altitudes of triangles. You should see this sort of near the top of your page. Okay, so the very first thing is it says medians. A median is a line segment that connects the blank of a triangle to the blank of the opposite side. It connects the vertex of the triangle to the midpoint of the opposite side. Okay, so there's no special characteristic about this one. It doesn't have to be perpendicular. It's not an angle bisector. It's just a line connecting the vertex of the triangle to the midpoint of the opposite side. So the first thing you want to do is you would want to measure this line and actually find the midpoint and then draw your line. I can't do that on a computer screen for you, so we're just going to imagine that that's what I did. And I would draw my line from this point, this vertex, all the way down here, and I would mark my sides congruent. And that's how I construct a median. This line is called a median because it goes from the vertex to the midpoint of the opposite side. So in this one, we're super lucky because we don't have to construct our midpoints. They've been constructed for us. We've got triangle ABC, and then AS is a median, CR is a median, and BK is a median. So once these have been constructed, we know that every side is going to be separated into two equal parts. These are not perpendicular bisectors, but they are lines that go from here to the midpoint. If we know that a point is a midpoint of a line, then we know of a line segment, then we know that the segments on either side of it are congruent. So we know that BR is congruent to RA. We know that AK is congruent to KC. We know that BS is congruent to SC. Don't forget to mark this stuff up. Dash, 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 dash. All right. All of these medians intersect at point U. When the three medians of a triangle intersect at a single point, that point is called the centroid of the triangle. Okay, and this has kind of an interesting relationship with length. So we've been talking a lot about midpoints and bisectors, things that are cut in half. This is another fraction relationship because the centroid is located it's not always located the exact number, so we don't have a constant number, but we have a constant ratio. The centroid is located 2/3 of the distance from the vertex to the midpoint. Okay, so if this is x, if the AS is length x, then we've got 2/3 x from A to U and 1/3 x from U to S. 2/3, 1/3. Okay. The centroid divides each median in a ratio of 2 to 1. 2 to 1. Okay? That means that this right here, basically, US is 2 of AU. Or is 2 of US makes AU. Or half of CU is RU. So if this one was 2, this one would be 1. If this one was 3, this one would be 1/2. If this one was 10, this one would be 5. So on and so forth. So we're going to do some practice with that. We've been given this triangle CDE, where U is our centroid. We've been given some lengths, and we're going to find our other distances. Okay, so to find CU, we already know that UK is 12. And we know that the relationship that CU has with UK is that CU is twice UK. So to find CU, all we do is multiply 2 by 12 by 2, and CU is 24 units. Okay, I know that because it's going to take 2 of these to make this. This is 2/3 of the way. 2/3 of the way down CK. Right? MU. If we want to find MU, this one's a little bit more interesting because what we were given in the problem, it's not marked here, but what we're given in the problem is that EM is 21. EM, the whole thing is 21. So we know that UE is 2 MUs. UE is twice MU. UE is twice MU, twice the length of MU. We also know that MU plus UE equals EM. And when we use the substitution principle and simplify, basically we find out that it's going to take 3 MUs to make all of EM. And then we already know EM, so we can substitute in 21, and we find out that MU is 7. To find CK, we know that CU plus UK is CK. We've already found CU, so basically all we have to do is add 24 and 12, and we know that CK is 36 units. And then we look at JU. We want to find JU. JU is, if you're confused about which one is the 2/3 and which one is the 1/3, remember that the centroid is 2/3 from the vertex to the midpoint. So we go 1, 2, and then the 3rd is the last leg. So knowing that, we can see that to find JU, 2 JUs is 1 JD, 2 JUs is 1 UD. We know that UD is 9. So when we divide both sides by 2, we find out that JU is 4.5. In our lab, this has not been explicitly put anywhere in your notes. You might want to make a note of this here, or maybe on your very nice handy vocabulary sheet. An altitude is a perpendicular line from a triangle's vertex to the opposite side. Okay? But it can be a perpendicular bisector, but it doesn't have to be. It doesn't have to be. It does not actually have to meet the definition of perpendicular bisector. We're going to see some altitudes that are not necessarily